The mass m grams of a substance is increasing exponentially so that the mass at time t hours is given by this equation. Find the time taken for the mass to increase to twice its initial value, and deduce the time taken for the mass to increase to 8 times its initial value. Find the rate at which the mass is increasing at the instant when the mass is 400 grams. Let's have a look at this then. Okay, twice original. So that's mass. So when would it equal 2m? What time would it equal 2m? So, okay. So 250 e to the 0.021 t, that would be the mass. It's going to equal twice the original time. So that will be twice what the mass is initially when t is 0. Well, you get 250 to start with, don't you? So it's 250 in the bracket 250, which is 500. Okay, so we could cancel just by 250 both sides, couldn't we here? Which is probably a better thing to do. So that tells us then that 0.021 t, take the exponential down to be the log of the 2, and then that tells us what the time is. T is equal to log 2 over 0.021, and we get the time, and that's in hours. So log 2 then, divided by 0.021 equals 33.00, so it's 33.01, wasn't it? 007, wasn't it? 007, which is 01 hours. And that was to 2 decimal places. So that's the time taken for it to double in size. You'll take, so the time, deduce the time for it to be 8 times, but we would need to double again, so it would be the same time again. Here, or it would be log 8, wouldn't it, over 0.021, so it would be 4 times that. So let's just check it is, because it would double to twice, and then double to 4 times, and double to 8. So it's double, 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 it's 3 of these. So times this by 3, 99.021, 99.02, to increase by a factor of 8 takes 99.02 hours. That's to 2 decimal places. And we could try log 8 over 0.021 to just check it. Log 8 divided by 0.021, which it will be, because that's 3 log 2. There it is. Okay, that's fine. So we deduce that. It take factor of 8 takes deduce. So it's that's part 2. Part 1. Part 2. Find the rate at which the mass is increasing at the instant when the mass is 400 grams. So here's the formula. The rate at which the mass is increasing. M is equal to 250 e to the 0.021 t. So the rate of increase of mass with respect to time. E to the something differentiates to e to the something. 250 lots of. Multiplied by the something differentiated, which is this differentiated, the something, 0.021. And when does that equal 400? When find the rate at which the mass is increasing at the instance when the mass is 400 grams. When the mass equals 400, so here 250 e to the 0.21 t is equal to 400 at what time? Let's have a look at this then. E to the 0.21t naught is equal to 40 over 25, which is 8 over 5, or 1.6. 16. 8 over 1.6, there we go. That's that. So then we can take logs. So 0.021t is equal to log of 1.6, and then move the log of natural logarithm, move the 0.21 from times to divide over 0.021. So there's the time in hours. So the MDT, the rate of increase of mass with respect to time, at this time is equal to, well, hang on, this value here is the value of m, isn't it? Which is when it was 400, which we did all that work, but all we need to do was put 400 in here, times which would have saved a lot of work. So 0.021 times 400 equals 42 over 5, 84 over 10, which is 8.4 grams per hour. That's the rate of increase. Yep, okay, 8.4. So this work really was unnecessary here. Simply because this is the mass equation here, which we know was 400, so we could just simply put it in here times the 0.021 and get the answer.